Okay, if we scroll down, the next topic that we have is signal conduction in nerve fibers. We said we'll have two main types of fibers. We are going to have the myelinated and unmyelinated fibers. Okay, if we scroll down, we can see here this unmyelinated. You see there's no myelin sheath covering the axon. Inside is negative. It needs to become positive, right? Sodium goes inside, so everything goes from negative to positive. In order to do that, you need to open channels for sodium, and that allows sodium to go inside. So let's say that from here to here, there are 100 channels for sodium, and you need 1 second to open each channel. Okay, just for educational purposes, let's say 1 second. So then how many seconds it will take you to take the information from here to here? Since you have 100 channels, then it will take you 100 seconds, because you need to open every single channel from this point until the end. So then how long does it take you then to go from this point to this point right here? It's going to take you 100 seconds. So let's scroll down. Let's take a look now at the myelinated fibers. You have right here the axon, and we have 100 channels, same as the one before. The neuron is negative. Now channel for sodium will open and sodium will go inside. However, but most of the channels are going to be covered with the myelin sheath, which is this. So the only channels that are going to be open are only these channels that you find in the nodes of Ranvier, which are the spaces between each set of myelin sheath. So if we said that we have 100 channels from here to here, then you don't need to open all the 100 channels, because most of the channels are actually covered with myelin sheath. So then let's say that in here, then how many channels we have? Let's say we have 2, 4, 6, 8, 10 channels. So then in this case of the myelinated fibers, we need to open 10 channels only. Since we said that we need to use 1 second to open each channel, it's going to take you only 10 seconds. Why? Because you need to open only 10 channels. And 10 seconds is faster than 100 seconds, which is the one that we were talking about with the unmyelinated fiber. In conclusion, the myelinated fiber transfers the impulse way faster than the unmyelinated fiber. Since in this case you need to open every single channel, then this is called in the unmyelinated continuous transmission. In the case of the myelinated fiber, since you need to open only the channels that you have in the nodes of Ranvier, the stimulus jumps from here to here, the stimulus jumps from here to here. So this one is actually called saltatory conduction. Right here, for example, you see saltatory conduction. And that's about it for this part. Okay, the next topic is synapses. Similar to what the neuromuscular junction is, in the case of a synapse, is a communication between a nerve and another nerve. Okay, so we can scroll down. When we talk about the neuromuscular junction, we said that the nerve is going to release acetylcholine. We can consider that the neurotransmitter acetylcholine is excitatory because it's going to make you move your hand. But you have to understand that it cannot be that the same acetylcholine is going to make you stop your hand moving. So that means that there are different kinds of neurotransmitters. And that's the next topic that we have in here, neurotransmitters. Obviously, we are not going to talk about how the neurotransmitters were discovered or anything like that. But there's something that you need to know, which is the structure of how these neurotransmitters are going to be formed. You have an example in here of how the neurotransmitters work, and this is obviously something we already covered with the neuromuscular junction. The nerve releases a neurotransmitter, and in this case, since this is a nervous system, this is another nerve which has receptors for the neurotransmitter. I think that's something that we already covered. And right here you have the neurotransmitter. So there are different kinds. Some of them are going to be excitatory, some of them are going to be inhibitory, the same way the gas makes your car move and brake fluid makes your car stop. Neurotransmitters, there are different kinds, and they fall under the category of acetylcholine, amino acids, monoamines, or neuropeptides. Obviously, within each class, you're going to have excitatory and inhibitory, and if you scroll down, you have a table in there that is going to show you the different kinds of neurotransmitters that we have under each category. So if we scroll down, GABA, for example, is inhibitory. So that's going to make you stop. And we said acetylcholine is excitatory. Synaptic transmission. They're just giving you examples in here. We said excitatory has to be acetylcholine. So acetylcholine is going to help you move your hand, for example. Inhibitory, I told you that inhibitory can be GABA. That's one example that you have right there. So if we keep scrolling down, you have more examples. And cessation of signal. So how do you stop these signals from continuing transmitting? You're going to take back the neurotransmitter into the neuron. That's a reuptake. In some cases, the neurotransmitters get released, but they reach areas where there are no receptors. So they just get reabsorbed and destroyed. And the other one is degradation at the level of the synaptic cleft. Like in the case of the acetylcholine, there's an enzyme in there called acetylcholinesterase that is going to destroy that particular neurotransmitter. Neuromodulator. Some neuromodulators are going to be, for example, nitric oxide. So the job is just to enhance the response of the neurotransmitter. Let's keep scrolling down, and that's it for this part. Okay, the next topic is neural integration, which means that you have a lot of neurons and they work together, but everything is coordinated. For example, you have neurons that help you with vision, and you have neurons that help you with hearing, but you can do both at the same time. And I said if most of them are positive or excitatory, then you're going to get an excitatory response. You have it in here. And if most of them are negative, then you're going to get an inhibitory response, as you can see right there, inhibitory response. Okay, so we keep scrolling down. Summation, facilitation, and inhibition. If you have 80 that are going to be positive, one of them is going to give you one stimulus. The second one, another stimulus. The third one, another stimulus. Little by little, you start adding up. That's summation. So you just continue stimulating, whether that's going to be excitatory or inhibitory. In here, they are trying to show you examples of summation in order to get the response. Same concept in here, excitatory, you get 1, 2, 3, 4, 5. Eventually, you're going to get enough in order to get an action potential. We keep scrolling down. Same thing, inhibitory and neural coding. Groups of nerves are going to be specific for vision. Some other nerves are going to be specific for hearing, but they are already coded that way, especially for quality, meaning, for example, the eyes make you see light. So even though you are touching your eyeball, for example, touching is not light. However, the eyes respond by producing light when you touch your eyes. That's quality. And quantity, a lot of times, depends on how many neurons are going to fire. So, for example, in here, if it's only 2 grams, only a few neurons fire. But if it's 20 grams, a lot of neurons are going to fire. So it gives you an idea of how strong the stimulus is. We keep scrolling down. The next topic is neuronal pools. It's a pool because the neurons don't work alone. They work in groups. We scroll down, we are going to get to this figure where we have the neuronal pools. So the first one is divergence. So for example, you have light, and with light, you will be able to see with this set of neurons. You're going to be able to maintain equilibrium with this set of neurons, and this set of neurons are going to tell you that you are awake. Converging, for example, this is the nerves that are going to help you move your diaphragm. When you inhale, these nerves are going to help you inhale and you move your diaphragm. But in order to exhale, you use these other nerves, and that's going to help you move your diaphragm. Reverberating, using the same example of inhaling and exhaling. This one is inhale, exhale, inhale, exhale. You need to go back in order to trigger this process again. So that's what is called reverberating. Parallel after discharge, you step on a piece of glass, you say ouch with this one, and you move your feet away from the piece of glass. These two things happen at the same time. That's parallel after discharge. Okay, scrolling down, we can see here the definition of parallel after discharge, but the next topic is memory. Okay, so let's take a look at that. There are 3 types of memories: immediate memory, short-term memory, and long-term memory. Immediate memory is the one that you remember only for a few seconds. Like, for example, you are reading something and you remember just those words.